Welcome you all for today's topic transformer. Here we see construction principle and working of the transformer. Transformer is a static electrical device. It is used for converting low alternating voltage into high alternating voltage and vice versa. It transfers electric power from one AC circuit to another. It works on the principle of Lenz's law of electromagnetic induction. Construction. It consists of two coil windings, primary coil and secondary coil, insulated from each other. The winding connected to the AC supply is known as primary coil. The winding connected to the load is known as secondary coil. The two coils wound over the core. The core is made up of laminated sheets of silicon steel to reduce eddy current loss of power. There are different shapes of laminated sheets. Working. An AC input is applied across the primary coil. When it is applied to the primary coil, the magnetic flux linked with each turn goes on changing at the rate of frequency of AC supply. The coil is wound over the core, so the changing flux is associated with the core also. The secondary coil is tightly wound over the core, so there is tight coupling of flux lines with the secondary coil. As the flux associated with the coil is rapidly changing according to the Faraday's law of electromagnetic induction, an EMF is induced in the secondary coil. This induced EMF is proportional to the rate of change of flux and number of turns in the secondary winding. Here E is equal to d phi by dt into N2. This term d phi by dt is the rate of change of flux. N2 is number of turns in the secondary coil. Since same flux links with the primary and secondary, an EMF induced per turn of the two coils must be the same. If a load is connected to the secondary coil, an induced EMF drives a current through the load. So, electrical energy transferred from primary to the secondary coil. The induced voltage in the secondary coil is 180 degree out of phase with the voltage in the primary. This figure shows the rate of change of flux linked with the coil. Here F is the frequency of AC supply and phi m is the maximum flux in the core. The RMS value of induced voltage in the primary coil having n turns V1 is equal to 4.41 N1 F phi m. RMS value of induced voltage in the secondary coil having N2 turns V2 is equal to 4.44 N2 phi m. Here, using these two equations, V2 by V1 is calculated as N2 by N1. The term V2 by V1 gives voltage transformation ratio. If N2 is greater than N1, then V2 is greater than V2. Here, the transformer stepping up the voltage for step-up transformer. If N2 less than N1, then V2 less than V1. So, the transformer stepping down the voltage and works as step-down transformer. For an ideal transformer, apparent input power is equal to apparent output power. Power is equal to IV. So, input power is I1 V1 and output power is I2 V2. From this equation, I2 by I1 is equal to V2 by V1. From the previous slide, V2 by V1 is calculated as N2 by N1. Then you apply here. Here the ratio N1 by N2 is known as turns ratio of the transformer. and the term I2 by I1 is known as current transformation ratio of the transformer. Thus, in the transformer, the ratios I2 by I1 which is equal to V1 by V2 which is equal to N1 by N2. So, the turns ratio of the transformer depends on the power handled by the transformer. Thank you.